Welcome to B-Sides Las Vegas, ground 1234 track. This talk is entitled Improper Database Authentication by Mitch from Canada. We'd like to thank our Inner Circle sponsors, Critical Stack and Valley Mail, and our stellar sponsors, Amazon, BlackBerry, and Silence. Please ask you to put your phones on silent, and there will be some time for some questions after the talk. Just raise your hand, I'll come by with a microphone, and then the streamers can pick you up. Okay? Take it away.
Okay, thank you. So, yes, like you said, my name is Mitch. I'm a software engineer, so not a security analyst, and I work on Cisco's advanced malware protection for Endpoint's product. That's about all you're going to hear about Cisco, though. All right, so we'll jump right into sort of the environment I work in. Just one slide on this. And I'll just describe a little bit about how endpoint protection is set up in the cloud in our case. So we have an agent running on laptops, servers, phones, sends data back to our command and control servers. It sends out definitions, so think like behavioral signatures, hashes, some machine learning, proprietary analytics. I don't know. I don't write endpoint software, so there's probably a ton going on there I don't know about. But the part I want to focus on is this data. It gets sent back, we take it into a streaming service, and it gets forked off to either have detections run on it, those generate alerts. Alerts get viewed by customers in their web portal. The other side is the data comes through, gets written to Cassandra, another database, and that raw data is kind of like an abridged version of what happened on the endpoint. So think like event tracing for Windows. You can get a ton of information out of there. There's no way we can bring all that back to the cloud for 7 million endpoints. So what customers get to view here is a bit of like an abridged version of what happened on the endpoints, but it still is like a deep enough picture for investigation. And then the sort of last data flow here is some generic customer information. It's put in MySQL. So you can think like admin names, I don't know, whatever you'd configure in your Cisco AMP for Endpoints web portal. So we care about data security, one, because we're a security division. Be a little embarrassing if we didn't. And we're also storing sort of two classes of sensitive data here. One is data about customer systems. So think like files, like a PDF could have some valuable business information that hackers want access to. We might have some information on that in here, so we want to protect that. Same thing with their alerts in terms of like what's going on in terms of cyber events in their system. And then lastly, kind of like your generic customer data you think about that gets leaked on the regular. Right now you see these leaks in the news, so we want to protect that sort of stuff too. So now an important point to bring up here is the scale of the data in our system, and it's going to come into play why I care about certain things in database authentication. So this data path right here is about 200,000 records per second in our largest AWS environment. And it's like a distributed systems technology has evolved where it's not that hard. I mean, not that I'm saying our jobs aren't hard, but it's possible. It just makes it a huge pain in the butt to, for example, do a rolling restart of this Cassandra cluster. Not that it's impossible, it's just that, like, for example, if you want to change a password for a database user or drop a user, if that happens regularly enough, we don't want to be restarting the cluster. If we want to upgrade, that's fine, but a routine thing like cred rotation should not be cause for restarting the cluster. Okay, so the interesting edge cases for me here are credential rotation, user deletion, and session invalidation. And a lot of these are coming down from an audit we're about to go through, and to pass an audit, we need to kind of like rigorously understand what's going to happen with the different data stores we use. So that's what we'll be looking at. We'll be evaluating MongoDB, Cassandra, MySQL. Those are the three databases you saw in there, as well as Postgres for good measure. So 4 popular open source databases. I think Oracle still has the crown. I didn't want to navigate getting an Oracle license for the purpose of this, so it's not in here. Right, and then the no downtime emphasis there. A lot of the things I'm going to bring up that are like possible issues you might care about, an easy way out is just downtime, restart your databases. So I keep that in mind. None of this is like the house is on fire type of stuff, even if I think later on I will show you, I guess it's a 1-day now vulnerability in MongoDB. Again, it's nothing to like seriously panic about. Okay, so this is a bit of an obligatory slide. Favorite meme there, but it's authentication versus authorization, just basically to convince you I know the difference. I think in the abstract, I sort of aliased them behind like the auth short form. Primarily going to be focusing on authentication, though it's hard to talk about one without the other, and we'll see some of these databases sort of lean on their authorization features for authentication functionality, in a sense. All right, so we'll go into some behavior examples here for these 4 databases. And the first thing we'll look at is credential rotation. So, I don't know, just like change the password. Those are two passwords that came off like a top 20 list I found online. I don't know, it's like, hey, does anyone here use those passwords? Yes? I don't know. I don't know who puts I love you for their password. That one just struck me as a little weird. All right, so this will be the format for the sort of like demo slides. So here we have 2 terminals, one on top, one on bottom. They're both user terminals for MongoDB in this case. So I got their little logo here. So the top one, we log in to a Mongo shell. And Mitch is a read-write user on the database. That's the pattern I'm using in most of these. And you can see we successfully insert, and then behind the scenes in an admin shell, the admin changes the password for the account Mitch. And you can see we can still use this session to insert records. You can read them too, but I just thought writing, it produced shorter output on the console, it could fit all on one slide, and it sufficiently demos it. And then the next one here is kind of like, I'd call it table stakes for being a database company. If you change the password, then you can't establish new sessions with the old password. Anyway, no surprise there. So you can't use the old password, password1, after it's been changed, but you can still use your old session. All right, so we got this table here. MongoDB gets a green no for use old creds in cred rotation, and a yellow yes in use old session. Not necessarily bad. You just know about it, I guess. All right, so going to Cassandra, similar behavior. Again, you can insert, admin changes the password, still use the session to insert, can't use the old password. Pretty straightforward. Cool. So no surprise there. Postgres, again, insert, change the password, and still insert with that same session, and can't use the old password. All right, no surprises again. There's a bit of a pattern here. So in MySQL, exact same thing. You can insert, keep using your session on credential rotation. Be kind of handy behavior to have, especially you want the ability to not kill all sessions. You can think like we have all these apps writing to Cassandra, for instance, and to kill all those sessions, have them reestablished. That'd probably cause a bit of a blip in our backlog. Might take a little bit to catch up, provision more servers, something like that. So I actually kind of like this behavior. Again, you just want to know about it. All right, so move on to user deletion now. So, sorry, Spidey, gonna get ready there. Does anyone like Avengers? I haven't even seen this movie. Did I use the meme right? I don't know. All right, so first we'll look at user deletion with MongoDB. So admin drops the user, and we could insert previously. We can't insert anymore. So here's sort of like our first, what I'd call interesting behavior. You still have a session to the database, even though your user's gone, and you can still sort of do stuff. Like non-privileged operations, so you can't insert, but you can, for example, send a command to the database. We'll see in the case of like MySQL, Postgres, you can send SQL, it'll parse it, check if you can do it. So it's not the same as having no connection at all. You have slightly more access. And then again, sort of the table stakes scenario, you can't use the old user after it's been dropped. So no surprise there. All right, so in this table here, I'm filling that in as not really. Can't do what you could before. Still can do a non-zero amount of stuff, even if it's not very much at all. Again, not something to go nuts over, just good to know about. All right, so Cassandra, again, similar situation. You can insert, admin drops the user, can't insert, and then Cassandra, you can get a little bit more out. So in the Mongo one, I just like asked for connection status. I couldn't do something like this, which was describe like what tables there are or describe what databases there are. So Cassandra lets you get away with a little more, but still very similar behavior. And then Cassandra is also a unique case in that it's the only one of these 4 databases where authorization is optional. So you can have a Cassandra database with user accounts and no authorization. So you just log in and you have full access to everything. So if you have authorization off, when you drop the user, you can just keep on going. So you have a session established, your account gets deleted, you're fine. Just keep on going. Anyway, so that gets it a red maybe. If you've decided to be lazy, didn't want to do authorization, you get this bad behavior. Again, something to know about. I'll summarize the things to know about at the end, but anyway, it's red. I don't like it. So now we go into Postgres. Again, similar pattern where you can insert, do operations until your user gets dropped. Then you can't except for unprivileged stuff. So here I'm saying like, show me all the tables that don't start with PG or SQL. There's like 50 tables in there that start with PG and SQL by default. So this is just showing the one data table. All right, so we get a not really for the use old session there. All right, and then MySQL can insert 4 users dropped. After it, you can't. And you can still do some things like show me what user I am to the database. All right, so not looking that crazy. Though there was something in here that hinted that things might be a little weird. So this Cassandra case where you turn authorization off and you still get your session, that sort of hints that this database is leaning on authorization capabilities to enforce authentication. So you don't have an account anymore. You shouldn't have an identity with the database, but it's using what accounts can do to enforce whether or not you have an identity. So that sort of begs the question. It's like, okay, so I don't have an identity. What if what if you recreate an account with that identity? So that's what we'll look at next, is recreating the user. And there are plenty of cases where you'd want to do this. So the credential rotation, remember we can still keep the session when you rotate credentials. Let's say you did want to kill those sessions. An easy way around that would be dropping the user and then re-adding it with a new password. So it's definitely a case you want to consider. And with Cassandra, you try to insert, admin drops the user, then you can't insert anymore, and then admin recreates the user, and you get a successful insert with that same session. So basically it's just checking, like, is there a user in there named Mitch? Yes, there is. All right, Mitch has these privileges now because they were re-added, and you're good to go with the old session because it's associated with Mitch. So not the best behavior, in my opinion. Not something I like. I'm going to have to find some sort of mitigation or workaround for my environment, at least. So now we go into Postgres. And Postgres, this is what I wanted to see. So you have a successful insert, admin drops the user, and we don't even do anything on this session here, no touching it. Admin recreates it with a new password, and we try something, and it doesn't work. We're back to the just regular drop user scenario. So this is what we want out of our database, I'll assert. So we get a nice yellow not really, because it's the same as the drop user. All right, MySQL. We're back to the behavior we don't like. Same as Cassandra, where we insert, admin drops the user, can't do it anymore. Admin recreates the user with a new password, and then we're back in business. Right? All right, so now MongoDB, this is the CVE that we're talking about. So thought it would be nice to give a live demo of this one, especially show sort of like why this is considered a bug, where, spoiler, the other ones I showed, so like MySQL, Cassandra, were not considered security bugs, and they're sort of more like things you should know about. So this right here is an admin shell for MongoDB. So we'll say like,
Can't see it.
oh, yes, thank you. Did not account for that. Actually, why don't we do this? Can mirror the displays. Okay, so we got an admin shell here. Is that good? Is it large enough font in the back? You good? You can read it? Awesome. Okay, so in this admin shell, we've created a user Mitch, password1, and it's a read-write role on this database. All right, so now we'll go over to another shell. It's in this container, and we'll go into the database with the user Mitch, password1. All right, so do things like show DBs, show collections. All right, so we'll try inserting something. That works. All right, so we're good. Then we'll go over here, drop the user Mitch. So now we'd like to not be able to use the session. Insert. All right, that's great. Requires authentication. Not my favorite that they mixed authentication and unauthorized in the same error code, but hey, it's the behavior we want. So now we'll add this user back. We'll use a different password, password2. Again, bad examples, but again, choose good passwords, please. Okay, so here we're going to try inserting again, and we shouldn't be able to. That's what we want. Okay, so that's good. Now, you'll notice here, though, we put activity on the session in between the user being deleted and the user being added back. So it was admin deletes user. We try and insert something, doesn't work. Admin adds the user back, and then it still doesn't work. So we'll try not doing anything on the session. So we'll log in. Password2 now. We can insert. Drop the user. Again, go back here. This is the user shell. We're not going to touch it. No activity on the session. And then we'll add this back. So we'll go password3. And then we try and insert again, and it works. So MongoDB clearly put some thought into the scenario where if you put some activity on the session, it sort of borks the session. And even if that user gets added back, you can't continue where you left off. But if there's no activity on the session in the meantime, then you can use it. So that's why when I report this to them, they considered it a bug, whereas Cassandra and MySQL don't consider it a bug. Okay, so MongoDB 4.08 gets a yes there. You notice I put the versions here. I think it's the latest version for all these databases except MongoDB. MongoDB's had a fix out for a bit now for that one, and I'll get into that fix in a second here. Okay, so I wondered, sorry. Okay, so I was wondering why is this behavior this way between these different databases? We have Cassandra and MySQL on one side, as well as MongoDB, and then the new MongoDB with its fix, and Postgres on the other side. So if we look at the user table in Postgres, we can see that there's this column called like uSysID in PG user. So here we have root and we have Mitch. And this is an admin shell, so we can go ahead and drop Mitch and then create Mitch again and then look at the user table. And you can see this uSysID value for the Mitch user change. So if this is too low, up here it says 16385 for Mitch. Down here it says 16386. So you have like a unique user identifier for each user account when it's created, even if the name is the same. All right, so again, that solves our Spidey problem. All right, so in MySQL, there's no such column in the user table. And this has been around for a while on their website. You're not meant to be able to read this warning, but basically it just says like, hey, the drop user command does not take effect immediately. The way they word it here, it's a bit, I think, pessimistic. The situation is better than they describe on this page. But basically it's saying like if you drop the user, don't expect sessions to be like gone right away. Cassandra, they're taking that route as well. Not modifying the database, but instead documenting it. They did not have something on their drop role documentation, which is the drop user equivalent. Tell them about this. They added it, so that's nice. There's a warning out there for everyone. And then, like I said, MongoDB, to their credit, this is great that they recognized it as a security bug. It shows that they really took it seriously, even though it's, in my opinion, not that crazy of a bug. And the fix they added in their 4.09 release, as well as their 3.6 and 3.4, which are also supported, is a unique user identifier. And in this case, they used a universally unique identifier to basically distinguish between two instances of users with the same name across time. Okay, so there's just a few possible actions here. Remember, if your database has authorization capabilities, use them. It might be leaning on them for some other security things like authentication, which is slightly different but related. The workaround for there being no UUID in your database user table is just create your own UUIDs kind of, so never make a user with the same name twice. I think that's the workaround we're going with, so we're going to do something like account name underscore the date it was created. And if you do that, you'll never have this problem of deleting and recreating a user in bad sessions maintaining activity. And then if you want that user ID functionality built in and you use MongoDB, just upgrade, you'll get it for free. I think that's about it. So I'll open up to any questions. If you want to get in contact with me, please do. wassonlabs.com. It's just a personal website. It's got email, LinkedIn, whatever. And then if you like this kind of stuff, Cisco is hiring pretty much on everything, but AMP for Endpoint specifically. We work out of Calgary, Alberta. If Canada isn't your thing, there's lots of security products as well in the United States and globally. Okay, I thought I saw a hand up over there.
Okay. Is there a way in Cassandra or MySQL or any of them to clear out sessions periodically? Can you disestablish sessions that have been established so that you don't run into this sort of thing over a long term?
Right. Good question. So I haven't found a convenient way. I've seen answers on the internet that I haven't tried out, which are kind of like custom scripting solutions. You might be able to do something in like your firewall, for instance, to like send like TCP packets that just stop sessions and force them to be reestablished. Something like that might be possible. Yeah, I don't have a super direct answer for you. Yep.
I assume you have tried this before.
Here, we'll just wait for the mic. Sorry.
Oh, sorry.
Yeah.
I assume you tried this before, but have you tried to kind of change the role of the user while they have a live session?
Yeah. So that's a great question. So for example, like the MongoDB one, you delete the user, add it back. The old sessions inherit the new permissions. So there's no kind of like keeping track of what permissions were what. It's kind of like you have a session that's established with a user named Mitch, and Mitch has these authorizations, then you can do it. So the CVE, if you take a look at it, it's got like a pretty high score. I think like 7.4. My initial assessment was more around like a 4, and it's that exact scenario, which it was Cisco Talos wanted it upgraded to that case. In case you take a user, delete it, and add it back with higher permissions, is what they were worried about. Other questions? There's one at the back there.
Did you look at the cases where, while there was an active session, you changed the authorization that the user had? How does it handle those cases?
Yeah, you get the new authorizations. If I remember correctly, you do get the new authorizations, yeah. More questions? Thought I saw a hand up over here. No? Okay. Anyway, I'll be sticking around. I know it's lunchtime, but please come up, talk to me. I'll be as candid as I can. Thank you.